Hey everybody, this is Miss Moriarty, and I'm here to discuss with us water availability on Earth and how we happen to use groundwater as well as surface water on Earth. So here we go. Okay, so we kind of already talked about this a little bit before we watched our explained video on the world's water crisis, but we know usable water on Earth is very limited as well as very rare, and that's because of the breakdown of water on Earth. Although the Earth is known as the blue planet, we know that majority of the water we find on Earth is made up of salt water, right? We find it within the oceans, and that's about 97% or so of Earth's water. And so that only really leaves about 3% or so that's fresh water. But then out of that 3% of fresh water, majority of that is trapped within ice as well as glaciers. And so really only about 1% of that is going to be actual usable water for humans. And when we look at the breakdown of usable water, lots of that we see underground, typically trapped within aquifers, and some that we see in surface water. So those are waters that we find that are lakes, ponds, and streams. So specifically looking at aquifers and groundwater, we need to know that an aquifer is a small space found within permeable layers of rock. Permeable meaning that it allows water through them, and sediment where water is going to be found. There are two types of aquifers that I would like us to be familiar with. The first is what's called an unconfined aquifer. That's going to be an aquifer that is simply just porous rock covered by soil. Typically, it's very easy to obtain water from an unconfined aquifer, and oftentimes it's also higher up in the surface, as opposed to then a confined aquifer. These are aquifers that are surrounded by layers of impermeable rock or clay. And so confined aquifers are really difficult to get water from. Oftentimes, we actually have to drill into the ground several hundreds of feet down in order to, again, get into that then trapped water in between those layers of impermeable rock. And so this is kind of a little bit of what I mean, right? So here is our confined aquifer. These are usually aquifers that are more difficult to obtain water from. You'll notice here we had to drill into the ground, right, several feet below in order to create a well where then we can create and generate water for then maybe household purposes. We see that confined aquifer is trapped between confining layers of rock that are impermeable versus an unconfined aquifer that has permeable either sediment or rock above it, which allows lots and lots of water to collect underground. You'll also notice another vocab word we should be familiar with is what's called the water table. That's going to be the amount of water that we'll see available underground. And usually it's the water table that you're going to tap into in terms of an actual well here. Also, what's called the recharge zone or recharge area. So whenever we see it rain, whenever we see maybe mountain melt, we see that water is going to collect in certain areas. It's going to then pass through that soil and sediment and then gather water over time. And so here, once again, right, I said the water table, that's going to be our uppermost level of water. Typically, it's fully saturated with the rock or soil. Our recharge, that's going to be the input process of water percolating into that aquifer. And springs are usually water from an aquifer that naturally percolate up into the surface. And so that water is going to actually be very pure because as the water passes through sediment and soil, it actually is a purification process as well. So that's oftentimes why we get a lot of our water from aquifers. However, when people then take water up through that aquifer too quickly before it can recharge, it creates what's known as a cone of depression. And so that's an area where there's really no longer any groundwater. We see that the water table is a lot lower than what it once was. And when we create that cone of depression, we can see now right? We have a lowered water table. And so these wells that were originally dug into the ground by a certain footage is now dry because our water table is far too low. Now, a very famous aquifer we should be familiar with is what's known as the Ogallala Aquifer. It's the world's largest known aquifer, and it's actually located in the United States, specifically underneath the Great Plains. Its water has allowed then farmers in that area to create very bountiful crops and grain, and it pretty much produces most of the grain we find right around the world. So we have to make sure that we take care of these aquifers, especially if they're going to be providing water for all of the crops that are going to be grown that we highly depend upon for our diet. Now, another effect of taking up too much water, specifically in coastal areas, is what's known as a saltwater intrusion. So you can see here, this is off of a coast. We see that we have salt water here, right, hitting up onto the coast. We see our fresh water underground. We have our water table here. We draw a well, but if we then pump the water out of the well too quickly before it can recharge, that salt water near the coast can actually infiltrate into the aquifer and contaminate your then drinking water. So you have to be very careful not to then overdraw your then water table and well when you're near the coast. Something else to look at, besides groundwater, we know other available waters on Earth are found on the surface in streams, rivers, ponds, as well as lakes. We know that surface water on Earth is incredibly important to maintain because they help to establish aquatic ecosystems, and we know it's us who depend upon the resources that those aquatic ecosystems will provide. So it's good to look at the productivity of those then surface waters. 3 vocab words we should know are oligotrophic. Those are going to be lakes that have low amounts of nutrients such as phosphorus and nitrogen, versus mesotrophic have a moderate level of productivity, and eutrophic has very high levels of productivity. If you can recall the word eutrophication, we know that's a process that is typically caused because of high amounts of phosphorus and nitrogen, which usually result in that green film that we can see on surface waters. Typically, you see them in like golf courses. But we know that those can be really bad because all of those nutrients is going to cause the algae in the water to grow at a tremendous rate. But over time, that algae is going to die and bacteria will come to decompose, and that bacteria is going to then take up all of the available oxygen in the aquatic ecosystem. So we have to make sure that we maintain the proper amount of nutrients and oxygen levels in our surface waters. All right, guys, that's the end of our video. Make sure that you took notes throughout the video, and please mark this assignment as done.